print down.
Right. So I don't know. I mean, that's the one I'm going to get but I mean, I wasn't going to get the 8 just because it's not really an upgrade, and I'm going to get a new phone. So the X is my option if I'm going to stay with the Apple stuff. I always get a newer Samsung as well for development. So they're all the same crap. At the end of the day, so I think it is compelling. The iPhone.
I was surprised they didn't do the plus size for the 10 too.
Well, what's interesting about the 10 is if you look at the specs, the 10 has a bigger screen than the 8 Plus, but it's a smaller phone. So the 10 is actually only slightly larger than the iPhone 8.
Oh yeah.
But the screen is larger than the 8 Plus, just because it's edge to edge. So I mean, that's an interesting thing. I mean, this phone. I mean, a lot of people think that this is the 7 when they see it with me, but this is actually the Plus. I'm big, but I could see, just slightly smaller might be just a little bit better than this. So, I don't know. It's just a phone, right? And, you want to have the latest gadgets, but we'll see how much they actually benefit from. I think the cameras on the 10 might be good for the augmented reality stuff. And when we go to the hackathon next Friday, we're going to do AR kit.
Yeah, that AR game they demoed at the keynote was pretty cool.
Yeah.
It was like you look at a table.
Yeah, I don't know if I'm sold on gaming for AR.
Mm-hmm.
I don't know how. One of the things was the one they showed, the thing that was like the Star Wars chess at the table, or did they show something else?
No, it was like a battle game where it's like it terraforms a table and like it's like an environment.
Oh, right.
Move around and look at
That's right. Yeah, so I mean, I could see that being kind of cool,
mm-hmm.
but then at the same time, is that gimmicky? Like after 10 minutes, is it not cool anymore?
Yeah, if anything, it's more gimmicky.
Yeah.
Because if people are going to play games like that, they're going to do it on a console or PC.
I can see there's quite a few practical applications for AR. So, for example, if you want to know whether something fits on this wall up here and you want to know how it's going to fit, you hold it up and it'll actually, you can say this is going to be a TV that's, this far angular, whatever, throw it up on the wall. I can see that. That's practical use for it. Measuring stuff, you can, if you want to, if you're at a place you want to measure how far something is, that you can do like a tape measure on a thing and actually just walk it along and actually measure the dimensions of rooms and stuff. Those are all practical, things that you won't have to go and run and get a tape measure, or have somebody hold the other end of it. You can actually trace around an entire room and it's accurate. Probably not to the millimeter, but if you're ballparking a room.
Right.
I don't know if you want to run out to the garage and start, cutting wood to match what you just measured, but it's probably in the, you have a pretty good idea this is an 8 by 10 room or something. I think those are practical applications, and that's where AR is going to really thrive, is that type of stuff. Gaming, I think, is going to be gimmicky. So we'll see. I mean, and now, it looks like Apple's all in on AR, and it looks like Google has an AR kit equivalent thing too. So what's going to be very interesting over, let's say, the next year is all the things that we're not even considering right now that the developers are going to do with AR.
Right.
What haven't we thought of? Because we're constrained by what we know or what we thought of, and some developer is going to come up with something like, oh my gosh, that's why didn't we think of that or something? That's how it always is, right? So we'll see. I'm a little miffed that the iPhone 10, I can't pre-order it until like the middle of October, and it doesn't come out till the beginning of November.
That was weird.
So my wife's going to have her new phone next Friday.
Yeah, so.
Yeah. But, I won't have a new phone, so I'm going to have this antiquated piece of crap. This is garbage. And then she makes the argument that, since she got the 8 and not the X, she actually saved money, so now she wants a new iPad too. And then I asked her, I said, so if I get you a new iPad, she wants the new iPad mini, but they don't have a new one, so she wants the newest iPad mini. I guess it seems like they're discontinuing it. Says, what do I get if I get you an iPad mini? I get to take her to this art festival tomorrow. That's my reward for buying the iPad mini. No. That does not sound awesome. And apparently I also get to carry her crap when she buys crap at the art festival. Do you want to take my wife to the art festival?
I would love to.
It's like, is it Holy Hill or something? There's, I don't know where. Oh, none of you are up on this art festival that's happening tomorrow? Well, apparently it's the big thing.
I work on Saturday, so would you pay me $10 an hour?
Yes. In a heartbeat. All right. Yeah. There's not that upper limit can go pretty high before we're going to start really having to negotiate. All right. What was the question for today? 130 and 131? Those are our two. All right, so 130, sort predicate pred LOI. So it's a list of integers, and so this returns a list of elements sorted by the predicate. Yeah, so that's interesting. Typically, I teach that predicates are functions that take single parameters and return true or false. It appears the book is using the definition that a predicate is a function that returns true or false. Because the example predicate they've given here is less than or greater than, which they take two parameters, right? So fine, whatever. So we'll operate off of that. So we'll come in here. We wrote sort last time, the sort blah. And sort blah is going to call find smallest, but really find smallest is just that's the guy that's going to change for this, right? Won't find smallest, just apply that predicate here. That's really the only difference in this question. So it's the exact same answer we have here. So, maybe we call this guy, let's call it find smallest. Let's call it find who? Find leader. So based on the predicate. Okay, so find leader. This guy is going to take in a list of numbers, a cur leader, and a predicate. And we're going to, this guy will return cur leader. This guy is the predicate. So if the predicate, when applied to the car of our list of numbers and our cur leader, then we'll call find leader helper on the rest. Find leader helper on the resting cur leader. All right, so find leader takes in a list of numbers, takes in the current leader, and a leader, there we go. And the predicate we want to apply, so instead of it being just automatically looking for the smallest number, we're looking for the number that gives us true when this predicate's applied to it. All right, so if we're out of stuff to look at, just return cur leader. Otherwise, if the predicate, when applied, so we are applying this function to these two parameters. That's what we're doing here. And that's the reason I'm saying it that way is that's kind of where we're going when we start writing language stuff. Okay, so this is called applying a function. We're applying the pred function, whatever that holds. Because what kind of value is going to live inside of pred? What kind of value will live in there? So is it like 4,000 degrees in here? It's like really hot in this room. What's up with that? Is it still like hot from Unity last night?
It was hot here before. It was hot here in the meeting last night.
Really? Huh.
It's supposed to be 80 degrees out today.
Yeah, but I mean, I was in the halls are a lot cooler than this, and I was just up in the library, and it's a lot cooler than this. I don't know. So that's why everybody's sleepy. So what kind of value is going to live inside of pred? Cat, dog, number, or lambda? Okay, lambda. So pred's a variable name. It's going to have a value. The value is going to be a lambda. And a lambda is a what? It's defined. It's just not named. It's a named function, right? So lambda is the definition. So lambda is the definition of the function. It just doesn't have a name until we assign it with a variable. All right, so pred is going to hold a lambda expression. So if this lambda expression, when applied to this parameter, the first element of our list of numbers, and the current leader gives us a true, which means that this would be the new leader. We don't necessarily know what this lambda is. We just know that it takes in two parameters, right? And we'll get an answer. If it's true, then we're going to go ahead and we're going to crown a new leader. So we'll call find leader helper, passing it the rest of our list of numbers, and its new leader is going to be this guy, and then the predicate is going to be the pred we just applied. Pass the buck. Otherwise, if this was false, we don't have a new leader, so we'll go ahead and call find leader helper on the rest of our list of numbers, passing it the current leader, and then also passing it our predicate. Make sense? All right, so that's find leader helper. So find leader, that's maybe how you might name that one. So this guy's going to take in a list of numbers. If it's false, blah, blah, blah. Otherwise, there's our find leader helper, passing it our... Now, find leader is going to take a list of numbers as well as a predicate. If we're out of stuff to look at, well, we wouldn't be out. Basically, if you gave me an empty list, I'm just going to return false. There's nothing for me to do. Otherwise, I'm going to call find leader helper, passing it passing it the rest of my list. Passing it my initial leader, who I'm just going to guess is the first guy. And then passing it the predicate. That makes sense? Now, do we need to do anything to remove first val? Or is that just looking for a val to take out of our list? We wouldn't call this guy until we've already figured out who the first leader is. So he's good as is. We don't need a predicate or anything for that. We're just saying, hey, here's a list. Here's the guy I need you to take out. Give me the list minus this guy. All right, so this guy's good as is. All right. Then what was the name of this function? Sort slash predicate. Kind of a weird name. Sort slash predicate. This guy's going to take in a list of numbers as well as a predicate. Is that the right order? Or does it have it go the other way? It has the predicate first. It doesn't matter, but just so when I copy the test cases in, it shows up right. So this guy's going to take in a predicate and then the list of numbers that we're going to sort. If we're out of stuff, go ahead and return the empty list that's sorted. Otherwise, we're going to cons whatever find smallest, but this is actually going to be called find leader now, on our list of numbers and our predicate. Then we're going to call sort predicate on our remove first val list of numbers. Sort predicate takes the predicate first, so I'll pass the predicate in. On the predicate, then the list of numbers will be the remove first val of list of numbers and the find leader of the list of numbers. Make sense? And then we'll call sort predicate here. And well, let's look at here's an example. So less than is going to do this in ascending order. There's 22358. If I do greater than, it'll do it in descending order. 85322. Make sense? All right, questions on that one? So that one should have been my feeling is that this one should, after you see the solution, or after you found the solution, it was easier than you expected it to be, but it was still hard for you to write because that whole thing with the pred And the lambda is still confusing for many of you. That's still a tough concept for us to wrap our minds around, that we're passing around functions as parameters. All right, but in actuality, many languages have this construct. What's it usually called in other languages when we can pass a function as a parameter to another function? It has a name for this type of thing. Pretty sure I mentioned it probably when we first introduced lambdas. Don't we all memorize everything I say? No, not even close. Not even, you don't even try. It's called a closure. A closure. So we'll go ahead and get that in our notes here. Well, by the way, I'll give the pitch again right now. Remember the hackathon, our first hackathon we're going to this year is next weekend. And we'll leave a week from today at around 5 p.m. We'll drive to Champaign, Illinois. We'll stay the night there. And then the next morning, we'll go over to the hackathon. It's 24 hours there. So Saturday from noon till Sunday at noon, and then we'll drive back up on Sunday. It doesn't matter how good you perceive your programming skills are. This is something that will benefit you. And I'll put you on a group that will complement where your skills are. But if you're going to participate in this one, I need to know today, like before 4 p.m., because I'm arranging for vehicles and accommodations and stuff. So if you don't let me know by today, then you'll have to wait till the next hackathon. I think the next one we're probably going to do is the Mad Hack in Madison. When's that?
October 7th and 8th.
So that'll be the next one we'll announce. But let's get past this first one. And what we're gonna do at the one next week is gonna do some augmented reality stuff. So depending on how many teams we have, we'll have at least one team of 5. But if we get more people, then we'll have a second, or even more people, we'll have a third. We're gonna look at doing some AR kit stuff for iOS 11 as kind of a new future-facing technology, and learn from that, and that should be kind of an interesting thing. They provide food and all that stuff, and it doesn't cost you anything. It's free.
There's going to be a lot of professional companies there for this one as well.
So potential internships, that kind of stuff.
The company that made Saints Row is actually based in Champaign, Illinois, and they're going to have a representative there.
Yeah, so punchline is an opportunity you really don't want to miss if you can swing it. If you talk to former students who have traveled with us to various hackathons. I mean, some hackathons are more underwhelming than others, but you'll learn something in any hackathon. School's kind of what you make of it. And if you take advantage of some of these opportunities, you'll not regret it after the fact. The worst that happens, you get a free trip, I guess we're going to call it that, even though you're kind of pulling an all-nighter. For those of you who can't stay up for 24 straight hours, that's okay. Probably at least half the people end up sleeping some. So you're not going to be like that one embarrassment that can't keep their eyes open. It's always funny when somebody falls asleep while coding. How many of you remember Jake Wirt? Or Jake? So we have a picture of him. I got to find that. It's really hilarious. This was at a hackathon we went to in Raleigh, North Carolina, and he's at the keyboard and he falls asleep, but he has like this weird Shaw thing on. He looks like an old woman. And there's no better way of putting it than that. But he's asleep, and you just imagine him, if he was awake, he would just be knitting or something. It's pretty funny. Yeah, so that was an interesting trip. We had like 14 people road tripping across the country to go to that one, and Tim Huseman and I flew. So I'm not sitting in a car for 17 hours. That's beneath me. All right, so do let me know by 4 p.m. today if you want to take advantage of that, so I can arrange travel and all that stuff. All right, so I was going to add closures here to this. Oh, the one other thing I'll point out while it's on my mind, and this is something from Tim mentioned to me at lunch today. He was saying he was recently looking at like jobs and internships and things like that, and he said that it's shocking how many jobs are in like virtual reality and stuff right now. So, and those are things that we're doing in the department, and so I encourage you to take advantage of some of those things, because it looks like a lot. I mean, you said it was a big percentage, right? So way more than half of the jobs are in VR and things like that right now. So that might be a skill set that you want to.
I posted in general on the slide about it.
Okay.
There's a link to the Glassdoor webpage that I was looking at with all the jobs.
So kind of an interesting thing of where technology is going, and I think you could probably tack on to that the VR stuff, AR stuff, augmented reality. So I think that's going to be a big deal moving forward. So if you want to prepare yourself for the workforce, or at least bring to the table to your job interview a skill that might set you apart from the next person in line who you're in competition with, those might be skills that will help you get the job rather than get interviews. Make sense? So take all those things into consideration. Okay, so we have this idea of a closure. So a closure is, and this is probably an oversimplification, but let's just use this because I think it's the easiest to understand. This is the act of passing a function, or in our world, a lambda, to another function as a parameter. Make sense? So most of our modern languages call this process a closure. Okay, so if you're ever working with like Swift uses closures, JavaScript uses closures, C# supports them, although it's not all that prevalent that they actually. Oh, what's weird's going on here? Let me finish getting dressed. Hold on. all recorded, and they don't they don't have the context there. Oh, speaking of context, remind me after class to talk about Luke chapter 1. Another Christian worldview, but when we talk about it, nowhere near a Christian worldview. I couldn't even hold it together last night. I kept almost laughing. If you want, I'm not going to talk about it here in class, even though I did read it yesterday, class. But if you look at the NIV translation of Luke chapter 1, I think it starts at like verse 22 or something like that. It doesn't read real clean to the American ear. So it's kind of a little Bible joke there. But yeah, see if you want to take a look at that. I think it's verse 22? Yeah, probably start at verse 29. Oh, no. Definitely start at verse 35. You don't have to go much farther past that. And I'm going to take this off the screen right now. Okay.
I caught that last night.
Did you see me trying not to laugh?
Yeah. I was trying not to laugh.
My wife and I were looking at it in other translations, and most of the other translations use an alternative word that rolls a little bit easier to the American ear. So it's did you? I almost didn't hold it together. It was pretty bad. Yeah. So take a peek at that. Okay. So closures. How did I get to that from talking about closures? Yeah. Whatever.
Something about context.
Finishing getting dressed, and then yeah, right. Okay. Yeah, so in a lot of our modern languages, Swift uses closures all over the place, and actually, interestingly, JavaScript, which isn't necessarily a very new language, uses closures all over the place. But what ends up happening is a lot of folks who learn JavaScript, they're not learning it while they're learning programming, they're learning JavaScript as a tool, so they're not really thinking about it. It becomes very natural for there to be a closure in JavaScript. Now, JavaScript usually calls them something else. Do you know what JavaScript calls these things? Usually they're called callbacks. Yeah, so do you kind of see the connection now? It's the same thing, but here's the function I want you to call when you're done. So it's going to pass that function a function that is the callback function that this function should call when it's done doing its thing. That's this idea. So this isn't something new, because what ends up happening in this class is we initially hear this lambda procedure thing, and this sounds very foreign to us. When the reality is we've been using these things forever and ever. Ever since you started programming, we just didn't call them lambdas. All right. So, next question. 131. Write the following procedures for calculating a binary tree. So this is definition 1.17. So we want leaf and interior node. These guys should build binary trees. Leaf question mark is going to be a predicate, which tests whether a binary tree is a leaf. And elson, arson, and contents of, which extract the components of a node. So is that left sun and right sun? Contents of should work on both leaves and interior nodes. Okay, so let me just quickly make a list of the guys we need to write, and then we'll go and look at definition 1.17. So we need leaf, we need constructors, right? So I'm going to kind of give us some definitions that will be familiar to us. So we're going to have constructors, leaf, and what was the other one? Interior node. Interior node. Okay, so those are the constructors we're building. Then we're building a predicate called leaf, which returns true if it's a leaf. So predicates. All right, so this allows us to test a binary tree to find out if it is a leaf. Then elson, arson, and contents of. So these are functions. Elson, arson, contents of, which extract the components of a node. So either the left component or the right component. Or give you the contents of the current node. All right, so now let's go and look at binary tree in 1.1.7. Before we even get there, what is a binary tree? Just based on our current understanding of binary trees, we've all had 300, right? Talk about binary trees in there. What is a binary tree? What's the binary part mean? Cat, dog, or two? Okay, it means two. One of these times, somebody's going to give me the answer cat. One of these times, I'm going to ask a question where the answer is cat. Then, all right. So binary means two, so up to two children, right? So a binary tree is a value, the value of the node, contents of, a left child, which is a binary tree, and a right child, which is a binary tree. Make sense? All right, so let's go to, what was it, 1.1.7? How far back is that? Am I too far? Oh, Command F. Good call, 1.1.7. Nailed it. Oh, lost it. Nailed it. All right. What's this dude called again? Something that looks like that. What's that called? Grammar. So that's a grammar. I almost said cat, dog, grammar. Lambda. Cat, dog, lambda, grammar. I wonder how many people I got to call a lambda there. All right. All right. So this is a grammar. Grammar is a list of starts with a P. Not procedures. Grammars contain productions. So it's a list of productions. So this guy has two productions. A binary tree is an int, or a binary tree is a list containing a symbol, followed by a binary tree, followed by another binary tree. Make sense? So we need two different constructors for a binary tree. Go back into here. So we need the leaf constructor. How do we construct a binary tree that is a leaf? What does a leaf look like? Just a single number. So leaf, define leaf to be a lambda that takes in a num. And what should this guy return? Here's my binary tree. This guy is just that number. That leaf? Okay. Other one is interior node. An interior node looks like this dude. So this guy's going to take in a symbol. That's the value of that node. And then 2 binary trees. Define interior node to be a lambda that takes in a symbol. Are they kind of referring to him as arson and elson? Elson, arson, okay. Does that stand for left sun and right sun? Yeah, isn't that's sexist, isn't it?
Yeah.
Should be child. Left child, right child. Book was probably written by a guy. Terrible. Right, ladies? I'm trying to have your back here. I'm trying to get ramped up for this art festival. I'm getting ramped up for this art festival. All right, so.
That's totally different.
All right, and what should this guy return? So I'm going to give it 3 things. It should return a what? Let's go back and look at our production. What does our production say that version of a binary tree is? Is it a list containing that crap? So we can say list of S, Lson, Rson. I think list will work on multiple parameters like that. Anybody confirm that? It does. So you can either do that, or if you really like the cons stuff, you can say cons S onto the cons of Lson onto the cons of Rson onto the empty list. That'll do the same thing. Make sense? The lists look cleaner, but it effectively does the same thing. So list S, Lson, Rson. So.
Interior needs a
A who?
Your interior needs a
Interior, like that. Nailed it. So yeah, I was testing you. That technically is not a syntax error, it's a spelling error. It's different. And it would have worked as long as I would have called it the right way with the misspelling. All right, so predicate for leaf. So we're going to define leaf to be a lambda. And what's this guy going to take in? What's the parameter going to be if we're testing to see if a binary tree is a leaf? Binary tree? Cat, dog, binary tree? All right, so this guy's going to take in a bin tree as a parameter. And how do we know if a bin tree is a, we want to return true if it's a leaf, false otherwise. How do I know that a bin tree is a leaf? Number bin tree. Number bin tree will boil down to true if bin tree is in fact a number. And it'll be false if it's something other than a number. And what if it's not a number, it must be a what? It's a list. It's not a number, it's a list. Okay, so if we were to write a second predicate here, we could define interior. See, I would have consistently misspelled that. No problems whatsoever. We could say interior, what node? Question mark. To be a lambda that takes in a bin tree. And this guy would return list of bin tree. So they didn't ask us to write that predicate, but you kind of see the alternative there. A binary tree is a leaf if it's a number. A binary tree is an interior node if it's a list. Now, this is assuming they gave us a binary tree in a legal format. You know, we could make sure it's a list containing exactly 3 things, but all right, now we need a couple of functions. All right, so one's going to be else on. Now, we probably could write this to specify whether we could assume that the input was accurate. Did it specify that? Do we have to check to make sure it's not a leaf, or should we? We'll be verbose with this. All right, so we're going to define else on to be a lambda that takes in a bin tree. All right, and then we're going to ask a question if leaf bin tree, maybe what, just return false? Bad news bears. You asked me for the left son of something that doesn't have left sons. Right? All right. Otherwise, if I'm in the else, I know I'm dealing with a interior node. Okay? And if I want the left son of an interior node, which part of it do I want? I don't want the car. The car is the symbol, right? Instead, I want the car of the cooter, the cadder, C-A-D-R, or if you want to say the car of the cooter. So this is I'm going to return the cadder of bin tree for else on. Define arson, lambda bin tree, if leaf bin tree, and you didn't have to write the if leaf bin tree part. If you wanted to just assume that you would only call this on interior nodes, that's acceptable. I'll give you a 0, but it's acceptable. Ha! All right, so. All right, so how do I get the right tree is this guy? How do I extract that guy from a list? Car of the cooter, or a stuttering cadder. Cadder. That's 3. Cadder. I can't do it. All right, so it's the car of the cooter. So otherwise it'll be the car of the cooter of bin tree. So those are the kinds of examples where those kind of shortcut car cooter things really are helpful. That's not having to go too crazy deep. We can follow those. But when you got to start doing the C, D, A, D, D, R, then you start losing your sanity somewhere in there. All right, so that's arson. So it sounds like Japanese, isn't it? Isn't everything like? Am I right? Like Daniel-san, isn't that a? Seems like you guys have way less fun in this class than I do. So it's disturbing to me. I mean, we've had Karate Kid references. You ever see the original Karate Kid, or you see the remake? Is Mr. Miyagi still alive? The actor? I think like Morita. So Rick Morita, something like that. You probably find out he's like 30. They just don't age. All right.
No, he's dead.
He's dead. Well, it was Morita, right? What was his first name? Pat Morita. 2005 at the age of what?
Born in 1982.
Okay. We could do the math, but it didn't do the math for us. All right. So who? Really? Probably too much tea. All right. What's this last part? Contents of. All right. So this should give us the symbol. So define contents of to be a lambda that takes in a bin tree. Bin tree. We'll ask if leaf bin tree return false. Otherwise, car of bin tree. Leaves and interior nodes. I don't know the answer to that. Is that what it said? What's the number? 1.3? Or that gets us close. Okay. Which extracts the component of a node. Contents of should work on both leaves and interior nodes. Oh, okay. Yeah, no problem. This will return false on that one. So if it's a leaf, no extraction necessary. We already have a value, right? Yeah. Otherwise, we'll extract the symbol, and that's the car. Although, is that the symbol, or do they want us to give the whole? I think that's the value of it, right? Or do they want the?
I think it would be the symbol.
Yeah, that's kind of what I'm.
Looking at the specific node.
Yeah.
So then, if you were to do like contents of the less on of bin tree, then it would be the.
Okay. So this all looked pretty good. All right, so let me copy this. We'll throw this into Slack. And then, escape. So we probably need to have a difficult assignment over the weekend because these last couple have been too simple. Right? No, if I'm going to an art festival, you are not enjoying this weekend. All right. Oh, this one's, oh. All right, so we'll do 1, 3, 2, 1, 3, 3. This 1, 3, 3 is terrible. Oh my gosh, that's start yesterday. 1, 3, 2, 1, 3, 3 for Monday. See everybody then.